Just a quick introduction for you guys so you know who we are. I'm Darren Pulsipher. I'm an enterprise solution architect at Intel, and I work in the data center group at Intel.
I'm Seema, Mehta, and I also work in the data center group. I'm the enterprise solutions manager, so I look at the enterprise solutions from discovery, planning, build and invest, and all the way to go to market. So.
Great.
Okay. So we will get started. So essentially, we noticed that the line of business is driving a lot of change. The developers that have, traditionally been developing applications for the public cloud, they're mainly interested in delivering products and doing quick iterations. Whereas the IT, in charge of a lot of legacy applications and mainly focused on optimizing for cost, making sure that data is protected and reliability. So, whereas the developers are continuing to do more template-driven deployments. Now the trend is also changing a little bit, and so with the private cloud coming up, the developers are also developing applications for the private cloud and as well as for the public cloud, and they both seem to be template-driven deployments. Private cloud is mainly built upon this infrastructure-centric, software-defined infrastructure approach, right, where they have more like self-service portals, orchestration and control, infrastructure including storage, network, compute, and security. So now the dilemma is that as the public cloud adds on services, like let's say encryption services or test services or messaging and stuff like that, now the developers are not only deploying applications, template-driven deployments to the private cloud, but now they are also exploring those services to make it more service-driven deployment. And with that, I'm going to hand it over to
Great.
Darren.
Are you guys seeing this in your organizations? Similar things? You developers, you like the public cloud, don't you?
Well, I'm on both sides. I'm actually in the operations team.
Ah, you're like me, yeah. No, they don't.
There's a number of operational things they don't do, like hierarchies open the whole world.
Yeah, exactly. So this is a major dilemma, right? Developers want to move very fast. IT wants all the security, protection, all that stuff, and traditionally move very slow. A great example at Intel, if I want to put a rack of machines in a data center, how long do you think it takes?
6 months.
If I'm lucky, right? 6 months if I'm lucky. The best I've ever seen it was 4 months. If I need a rack of machines, let's say 40 or 100 machines, running in the public cloud, I can do that in under 30 minutes, fairly easily. So there's this dilemma. And if you're on both sides of the fence, how do you capture? You need to capture those developers. So we've tried lots of different things. One thing we tried was adding more services to our private cloud. So if we're adding more services to our private cloud, we can't keep up with the public cloud because, why? What do you think?
There's 2 of you.
Yeah, there's 2 of me in my IT department, and there's 1,500 people in Amazon or Google or Microsoft. And look at their budgets. They're in the billions of dollars to create these new services. So we always tell people this dilemma that we have. How do I attract those developers back into a controlled area where I'm worried about cost, I'm worried about protection, I'm worried about reliability, compliance with brand new laws like GDPR out there? All these things play a big role. So how do I handle that? So we're going to show you some techniques that we found, not just at Intel, but one of the things that we do is we go out and talk to lots of companies all over the world and find out what they're doing to overcome this, and we give suggestions. So we got a lot of feedback from them, and we give them a lot of ideas as well. So we'll go through some of that right now. So, but before we do that, I want to teach you guys a little something about these creatures that we call developers. I'm a software developer personally. I'm such a geek in that way that when I relax, like on vacation, I have my laptop with me and I code. That's my way of relaxing. It drives my wife absolutely batty, And I said, you've got your Danielle Steele novel over there. I've got my neural network I'm programming. I think it's perfectly fair, right? Not a problem. So to understand these guys a little bit, let's take a look at them. So first, we know how to do this kind of development. Multi-tiered development we've been doing for probably 25, 30 years. So we understand this very well. We know how to set up these environments very easily, right? Normally I've got a web server of some sort. I've got my application logic, and I've got a database on the back end. 3 tiers. Sometimes I can even have 4 tiers if I'm lucky. We know how to build this. We drop it into Jenkins or Hudson, the old Jenkins, right? Or TeamCity or Bamboo, and we build this out, and it's no big deal. It's pretty straightforward. With cloud technology and new architectures like microservices, this changes things a little bit. So if I look at this here on the left, I've got my multi-tiered application, very well known and defined. It's been around for a long time. On the right is these more cloud-aware application stacks, and these are dynamic. Instead of dealing with 4 services, I'm dealing with dozens of services, and they can change every time that I deploy a new application, because I'm going to reuse services over and over again. So managing how they're all connected together, managing how many there are, and version controlling all of these, making sure everything's at the right version, and I'm getting security patches, is much easier on the left than on the right. Can you see that? Because I'm dealing with 4 things here on the left that I'm well known and I can reuse over and over again. On the right, I'm dealing with dozens and all the permutations you can imagine of those microservices. So what happens is the developer now has this mess on his hands. Because on his laptop when he's doing development, like I do with neural networks, I can deploy this on my laptop really easy. There's maybe only 4 or 5 services. I can do it fine. But when I go and push it into production, as you mentioned earlier, maybe I'm using Mongo for my database. I push that into production with 1 Mongo server running. What happens? It's not highly available. It will go down. I will get data corruption if I don't set it up properly. So this turns out to be a big dilemma. And these developers end up having to try and figure out, what does my application look like when it's in test environment? What's it look like in production? And most of them just throw their hands up and say, we'll deal with that in production. And it's a mess. Right? And you're like, oh, stupid developers. And then the developers are going back to the sysadmins. Those guys just don't understand. Yeah, exactly. Just give me root access, right? That's what they all say. So we've got to help resolve this problem. Now, the next phase that we've seen happen in this space is we've added something to this that's made it a little bit easier. And languages like YAML have come up and helped us out quite a bit, because now I can describe my services and the infrastructure they need using JSON or YAML file. And we see several different formats of this, from Cloud Forms, Ansible scripts. All these things can all be tied together. And now I can script my environments. So this makes it even easier. But you can still see, I still have a lot I have to manage. So it's still somewhat difficult, something I need to work on, right? And all of the onus ends up on the developer. Because how can the system administrators know about all the different services that I might want to use? So this is what we're seeing today. I see this over and over again when I go into organizations. A great example of one software as a service organization that everyone in the world uses, at least in the United States and Canada, is Intuit. Intuit was doing just this. I want you guys to think about this. This is a company that their program, their software as a service, 90% of their users use it for 2 weeks. The same 2 weeks. Right? Imagine what that's like. Yeah, it's TurboTax, right? Imagine what that's like. That's got to be crazy. right? So when they were going through this same dilemma, they ran into the same problems. Developers would be developing something and it works great in their dev cloud, and then when they promoted it into production, everything just kind of fell apart. So working with them, we found out some patterns of use that they were doing. What was going on? What were some things that we could help them out? As kind of this agnostic, stand back and take a look at it a little bit. And we found some interesting things. One of them is that a service, like here in local, when a developer is developing something, he doesn't need the whole stack with high availability and all that. In fact, he prefers not to deal with that. He kind of wants that to automatically be there, right? And then when he gets, and he's got his code all ready to go and he checks it in, he wants to integrate that with other developers. And in this case, as you can see, the number of services in there has increased because now another developer may be creating a new microservice, right? That maybe the two don't need to talk to each other, but they may be using some of the same other microservices underneath. So as this application grows, we need to not bog down the developer with all the details of what's going on. So we have a template-driven, where the template that describes the application and how all the microservices communicate is checked in with the code. And that template-driven application stack changes depending on the different environments that are there. Now this is where your sysadmins can get control of things back again. Because of regulations, because of intellectual property you want to protect or reliability, your sysadmins can define, and we have a unique name for these sysadmin types, we call them stack developers. They're developing these stacks of services that are reusable across all the different environments. So for example here, the green one is my MongoDB database. So running on my laptop, I just need one server. Running in test, I want 2 servers. So I can test failover and reliability. And then in production, I want 3 so I can go massively scale and have redundancy. Or I can do 4. Who defines what those are is not the developer. It's your sysadmin type that we call the stack developer. So he can develop a service that has a different life depending on the environment that it's in. Now when we helped Intuit come up with this concept, boy, things got a lot easier for them. Because they could have reusable services and then composite services, where I have a service that includes several other services, and you can go very deep as far as levels of aggregation. And then at the top, we called it an application stack, where if I went and I said, I'm writing a brand new Node.js application, I know there's certain things that I'm going to need automatically, right? So I include those in my application stack. So now when this developer goes and grabs that application stack to do Node.js development, it automatically includes everything that's needed in all the different environments, including production, including audit, log, compliance, protection, encryption, all those sorts of things can be automatically there for him. Now, does this seem like it's hard to do? What do you guys think? There's a lot of work involved, right? But it's a lot better to organize it this way than to do it for every single product that you have going out. And as you mentioned before, controlling those developers is very difficult because they're just going to go off and do whatever they want because they need to move quick. That's the thing. I need to move quick, right? So we've got to help them overcome that. Now, how do I actually implement something like this is another story. So let's talk about, and I'll show you a picture here of what we have. This is a high-level picture of what a hybrid cloud looks like. Because underneath all that and all those environments that we showed, you actually have a infrastructure that's flexible, that can run both on public cloud or private cloud, and even tie into legacy applications. I haven't met one company yet, well, maybe some startups, But most companies have legacy applications, legacy data that they need to tie into. They're writing applications on top of, maybe it's an old CRM system, or maybe they have a mainframe with COBOL running on it. Do any of you have mainframes? You've got a mainframe with COBOL? Yeah, how do you tie into those? So we need to come up with a strategy on how we can include those in these new application environments as well, without having the developer to have to say, well, give me an IP address and a port. And then I will just attach to it. That's craziness when you think about that, right? Because what if you ever change that IP address? You have no idea where that is in the code at all. So you need to come up with strategies on how to do that. With a hybrid cloud, the way we have it established here, a hybrid cloud gives me that flexibility. So here, as we saw before, you saw the developer knowing about public cloud, private cloud, and legacy. In here, the concept is that he can now define his application with a template, a set of YAML files or one YAML file, specifying all the services that he needs, as well as any legacy services that he needs to attach to by name. And then he submits that to the hybrid cloud. And then what happens with the hybrid cloud is the orchestrator here takes that information and then figures out, based off of policies established by IT, where to get those services from. So maybe it's opening up a port and creating an overlay network and opening up a port in a legacy application to connect to a private cloud to run analytics, and then maybe the results are pushed up into a public cloud as a API gateway to access that data that was just analyzed. All this could happen with a simple definition up here of the microservices and the requirements for those microservices. And then your orchestrator here can then put those microservices where they need to go, establish a VPN to connect all of those services together, and make sure that everyone is authenticated appropriately. Now, I wish I could come up here and tell you guys, I can sell you this today, but that is not the case, right? There are a lot of companies that are working heavily in this space to make this a reality, but in reality, I have some integration that I need to do in this space. So let's take a look at the integration. So to get a true hybrid cloud, as I kind of showed it, where everything is intelligent and dynamic and things, it's really the integration of these three types of products here. A cloud management platform, which really allows me to attach multiple clouds together, as well as legacy infrastructure, right? So that's my cloud management platform. There's some great set of tools in this space. In the Red Hat universe, you've got CloudForms Manage IQ, right? And there's several other startups that are in this space, and other large companies that are in this space as well, including VMware has a new cloud management platform. And then we've got the PaaS layer down here, where this is more service-oriented. OpenShift really fits well into this space. Cloud Foundry is another one that fits into this space well. And the PaaS layer is really geared towards developers, right? Reusable services. How can I reuse those platforms over and over again? And then over here on the left are the automation frameworks. Automation frameworks tend to be for the sysadmin types, or this new persona that we're calling the stack developer. So the stack developer really uses automation frameworks to repeatably deploy services over and over again, right? And because you can't just grab an image and drop it into a container and say you're done. I've got to connect services together. I've got to have user authentication, all that stuff put in there as well. So you really still need the automation frameworks. The integration of these three tools together is what can give you a hybrid cloud. Now, there's some good news in this space. Some of the good news in this space is that every single one of the key players in each one of these areas is moving to the center. Most of the CMPs are adding a PaaS layer to it. And they are integrating, or they have tie-ins with Ansible, SaltStack, Chef, or Puppet, any of the popular automation frameworks. We're also seeing a shift in the automation frameworks where they're starting to move into the CMP space, the cloud management platform space. And we're starting to see a move up into that space as well. So I wish I could just sell you one today, but they're not quite completely ready. But there are parts out there and pieces that you can put together. And we have several different recipes that fit in this space that if you guys come and talk to me later, I can point you in some directions on where to go. Okay. Now, some benefits of dev services on this hybrid cloud. So we talked about the developer services that I need, and we also talked about the benefits of the hybrid cloud. So let's marry the two together. So one of the things that I get here is, and people are surprised by this first bullet here. What I have found is in every organization I've been in, they all try and say, we're just going to containerize everything. Have you guys tried that? Have you been successful? No. There's some things because of network configurations or storage requirements or latency speed, you just can't do it. It becomes very untenable, right? So what we found is a good hybrid cloud has the ability to do orchestration of VMs, containers, and bare metal provisioning, right? Just like what you guys saw in the keynote this morning where they were using a director to do bare metal and VM provisioning. Did you guys see that this morning? That's a really good software-defined compute controller because it gives me that opportunity to do that. If I need to do bare metal, then we should allow you to do bare metal. So that's a key component of a good hybrid cloud. The multi-cloud deployment, making sure that I can span multiple clouds, both private, on-prem, private off-prem, or public clouds. And also keeping that legacy in the loop, being able to tie into that legacy. Managing the multiple environments from dev, test, UAT, performance test, cloud, you can come up with as many environments as you can imagine. Even multiple production environments, I've seen that, where they're switching between the environments, when you're doing a blue-green upgrade capabilities. Having those different environments is important. The other key thing is abstracting away the hardware and the infrastructure away from the developers. We're moving away from developers asking for a specific machine or even asking for a specific amount of memory, right? And instead, they're asking for services. And they're saying this service has a certain service level agreement or a quality of service. Then you have a smart orchestrator that can make those decisions. Right? So in order to enable developer services on top of this, we need to do some things here, right? One thing here is we need a good environment manager so I can easily manage all those environments running on my hybrid cloud. We need a good CI/CD pipeline like Jenkins or Hudson, TeamCity, Bamboo. Those are all really good ones out there. There's some new ones that are more SaaS-based ones as well. And then I really need a really good registry. Now the registry ends up being extremely important. And I can show you why right here. The registry here is where you're going to store any service definitions, images, whether they're container images or VM images or ISOs for bare metal provisioning. You need that common repository where you can store all your stuff that developers need, whether it's user mapping. So if I'm Darren and I'm running on my private cloud, and I'm Darren and I'm running in AWS, or I'm in Google or Azure or whatever it is, that knows that that's me. So I need to store user credentials and all that in the registry. Service definitions, data, even. Someone came up with a great use case just last week where they said, I've got a petabyte of test data. I said, a petabyte? And they go, yeah, when we run our tests, we run it against this petabyte of data, and we just randomly choose the data to run it against because it would take too long to run all of it. It says, how do I make that globally accessible, Darren? I went, oh, great. So we came up with a strategy, and one of the things that we added to it was adding it into the registry. Not all the data, but a pointer to the data in the registry. So having that registry is key. One of the reasons why is as I'm moving and progressing through my typical code pipeline here on the bottom, I'm generating and creating new services that are stored up into the registry and then deployed into production. So that registry becomes almost like what we used to do in the 90s with ClearCase. You guys are too young for that, right? Where we were storing derived objects up into, and all of our binaries up into VOBs, right? Up into these big registries, repos, so we could pull them down quickly so we didn't have to rebuild our software, right? It's the same concept here where I'm building my images, storing them up into a registry, and then pulling them down when I go into production. So it's repeatable, it's versioned, and all of that. Now, does this exist today? The good answer is, yeah, we have parts of it today, which Seema is going to cover real quick with OpenShift.
Thank you. So Intel is partnering with Red Hat to develop a fully containerized application platform using OpenShift. And so what it is it's a fully end-to-end solution with hardware and software end-to-end turnkey solution. It's a platform as a service, and it is, of course, using the enterprise-grade Kubernetes and Docker for runtime environment. So it's just really making sure that the DevOps theme is accelerated. What we have seen is that we can do a deployment within 60 minutes, the most 60 minutes, and this is quite accelerated versus in the past when it used to take about 5 to 6 hours. And of course, it's a fast method, and now we are seeing that with containers. Containers started mainly with the stateless applications, so the ones that were not persistent, but now with containers taking off, like, the estimates are that they would be, the market share is USD 930.4 million in 2017, going up to 4 billion in 2020. So the containers are really ramping up very fast and very rapidly. So with that, there is more need for persistent storage and stateful applications, right? So the applications that can have access to the storage in real time. So that's the container native storage. And that's what this is enabling. And that's mainly for like transactional workloads and things like that. So the differentiation of the solution is also really because it is a bare metal and on-premise solution built for high-performance applications for enterprise, small, and medium. But it's really, doing it from bare metal all the way up, running quickly, deploying it, the whole infrastructure up and running very quickly within 60 minutes versus 5 to 6 hours that it used to take before is really the value proposition here. And like I said, we are teaming up closely with Red Hat, working on the Ansible playbooks for automation scripts, and of course utilizing and harnessing the power of a lot of performance gains from Intel Xeon scalable processors to come up with this solution that's tightly knit and verified in terms of performance. These are just some of the, just one second. Stuff here. But this is logical architecture, so the PXE provisioning is again for bare metal provisioning. And this shows the architecture is, so we have like a combination of master nodes, bastion nodes, application and storage nodes, as well as infrastructure nodes. This can really be converted easily to a hyper-converged infrastructure because the workloads can be run on any node, and Kubernetes can be used as a scheduler to optimize workloads across any of these nodes. So it can really be easily scaled to a hyper-converged infrastructure. All the components here, for example, the Open vSwitch acts as a SDN, so software-defined networking function. And then we have, and OVS also has kind of establishes internal network to connect to make pod-to-pod communication. And then we have, some window came up here, so I can't see the, but, and then there is the Keep Alive, which is, establishes virtual IP. That's okay, thank you. So the virtual IP infrastructure here that allows the interaction of the nodes to the Red Hat console and the applications. Also, then we have the Gluster file storage system. That's, again, part of the Red Hat OpenShift. And it is managed by Hecate, which also serves as an API to the Gluster storage. So essentially, we are also using two operating systems. So one is Red Hat Enterprise Linux for the master node, and Atomic Host for, for the Bastion node, and Atomic Host for the master infrastructure storage and the application nodes. Then there's a extensible operating system on the Arista switches, again for the automation, and I've explained the Open vSwitch and the Gluster file system. There's a high availability proxy module or a node that is for load balancing and routing functions, again built into the whole cluster. And Keep Alive is where it's establishing the virtual IP connection or the network for the external Red Hat console and applications. So this is just really tightly knit, all the key functions in one cluster, in one architecture, with the storage and the infrastructure and the application and the master nodes. This is what, so we have been collaborating with Red Hat, and we are also partnering with OEM partners to create a reference design that would enable the solution benchmarked in performance, and then they can take it to the market. But this is where we are in terms of our DevOps acceleration and within the hybrid cloud domain.
You guys have any questions for us? You can get this today. I know we announced earlier today, specifically, we announced that Lenovo has an Intel Select solution in this space with OpenShift. So you can actually go to Lenovo and buy an appliance that has OpenShift installed and ready to go.
Yeah. So what Select is, it's an Intel brand for performance verified solutions. So what we do is we work with ISV partners and we create a reference design that is, has a recipe for the hardware, software, and the settings, and a configuration that is that must meet the performance benchmarks threshold, and for like a base and a plus configuration. So once it meets that, then the OEM partners, take that recipe and develop it on their, develop the reference design at their own end, compare it and validate their benchmarks with us, and then take it to market. So that way it has that Select brand, so it's verified in performance and it meets those performance threshold benchmarks.
Right. And like you mentioned, you can also scale.
Right.
Right? So if you need more capacity or throughput or whatever, you can just add to that through that Intel Select solution. All right. Any questions for us? We have a little bit of time, yeah. So we use several different benchmarks. Do you have the names of them or anything?
Yeah, so it depends on the workload, right? So the workload that we use for this is an e-commerce web application. It's called Magento. It's an open source web application. And for that, since it's an e-commerce application, we use the transaction per second. How many transactions can it take, can it support? Number of users in a certain time frame. What's the latency? So there are a set of KPIs that we defined that it must meet as a minimum requirement. How many instances of Magento workload can be deployed. So there are 4 or 5 of them that we are testing. And of course, the deployment time of the cluster itself, right? Like I mentioned, it should meet, it has been verified to have between about 60 minutes versus 6 hours before. So that is another benchmark.
Good questions. Any? Yep.
Sorry, say that again. So what's the thought behind having atomic host?
What the benefits or analysis was around using atomic host for the OpenShift nodes in the cluster?
Yeah, this is how it's defined by Red Hat, and you know, the enterprise Linux is mainly for the Bastion node, and then the atomic host just for agility and more flexibility is how it's defined.
Second question around CNS. Any particular challenges you've experienced?
Container native storage, you mean? Any challenges?
Yes. There's always challenges around storage with containers today. And there isn't a great story yet. I wish we had one. We've optimized the infrastructure for cluster, but we also have some that are doing Ceph or vSAN as storage underneath. It's an issue in the container industry as a whole right now that they're trying to address. So yeah, we have problems. Disconnected volumes disappearing. I mean, it's all over the place. Yes, you're not alone. Any other questions? All right, hey, thank you guys. We appreciate your time.